Hi, this is Miss Michael, and this is another short video, and we're going to cover the topic of genetic drift. So, we're here at the W.H. Freeman site, and this is a little simulation that I'm going to use to illustrate genetic drift. So, it says here for a population to evolve, its members must possess heritable genetic variation, which is the raw material in which mechanisms of evolution act. So one mechanism of evolution, genetic drift, it is random. It's not. It's almost the opposite of natural selection. So random chance events occur to a population that basically these organisms are just lucky. So genetic drift occurs when you have a small population. So if you look at generation one, it has two alleles. It has the dominant and recessive of a particular gene. And so the allele frequency is about 50%. If you look at this in generation one population, by chance alone, the frequencies of the alleles in the population change over generations. So if you look at generation 10, and then you look at generation 20, you can see that the gene pool of the population over this many generations has changed drastically. Small populations, when you have a small population, genetic drift, a change in frequency alleles is pretty drastic. So any allele, including a harmful one, may increase in frequency, or a rare one can become either lost or it can become more common. So in large populations, genetic drift, it can influence frequencies, but it really, you can't see that much of a drastic change when you have a large population. So let's look at this scenario here. Okay, so you have a population size of 1,000, and we're just going to go to 10 generations here to see the change in the graph. Okay, so when you have a population size of about 1,000 over 10 generations, you can see that the allele frequency is going to remain relatively the same. If we put in 100 generations, you'll see the same trend. It's going to be relatively stable. Now this is 10 times as many generations, but it's not going to change as much. Okay, so let's try reducing the size to 10. When we reduce the size to 10, predict, do you think that it's going to remain stable, or what do you think is going to happen? Okay, so here we have a situation where the population size is really small. It changes drastically. It changes drastically again, and then again it changes, and then you have lack of genetic diversity in the gene pool because it's that gene has been lost. If we just go to 10 generations, okay, you can see still that there is a shift. I'm going to clear this out and plot it again. Okay, so here you have the small population size. This is over 10 generations, and it seems to change drastically. And then at one point, it just, there's an allele that's lost. If you see that flat line, the allele is lost. So this is the allele for the dominant. So the allele for the dominant is the only gene left, where the allele for the recessive is completely gone. Now, if we increase again our population size, you have less genetic drift. Okay, you have just a very stable population. So it gives us question one. It says clear the graph and then set the number of generations to 1,000 and make several plots with decreasing population size. So we'll plot, and then let's take a 0 off, and we'll plot again, and then we'll take a 0 off, and we'll plot again. We'll take a 0 off, plot again. Okay, so as we decrease the population size, the frequency of alleles just kind of goes haywire. Okay, so we're going to go ahead and experiment again. We're going to clear the graph, and we'll set the number of generations to 50. And we're going to plot 2000. Okay. Can you all predict what kind of line we're going to see on the graph? Yeah, relatively stable. Okay. We're going to reduce the population to 200 and plot again. A little more dramatic. Okay. And then we reduce the population to 20. Okay. So you can see as the population is reduced, genetic drift, it is more drastic. And eventually, if the population is small enough, then you have an allele that can disappear altogether, and one that becomes the more popular in frequency. And so, if you want to experiment with this, it's whfreeman.com /brainhoney/resource. It will show you every time the amount of genetic drift that happens. So again, genetic drift is something that it's the change in allele frequency in a population over time. Genetic drift is going to be more drastic in a small population.